Alrighty, folks, sorry I can't be there today, but I am getting married this weekend. So exciting. Alright, I'm going to have you just try out the POD, the warm-up. You want to figure out the tangent function, figure out where the asymptotes are, the period, the range, all that jazz. Then we will get into the reciprocal function. So pause the video, try it out, see what you get, and then come back. Alrighty, hopefully you got your asymptotes where pi plus 2 pi n. So remember, usually your asymptotes are at pi over 2 plus pi n. Because remember, your unit circle at pi over 2, your tangent value is undefined, which is what an asymptote represents, and then the period is pi. If you set that equal to your x over 2, this value, then you're going to be able to actually solve for the asymptotes. Okay, your period is 2 pi because pi over b is 1/2, and you can solve. Your range is always negative infinity to infinity. And then remember, your normal midpoint is 0, 0, so you have to shift it up 1. Then your period is now 2 pi, so that means you go in pi both directions. Remember, pi this way, pi that way. And that means halfway between your midpoint and one of the asymptotes is halfway, which is pi over 2. Your amplitude, even though it doesn't have amp, is 1, so you have to go up 1 from there. And there you go. So negative pi over 2, comma 0 is 1.01, and then pi over 2, comma 1. If you're still having trouble with tangent, or you have trouble with today, let me know when I see you next. All right, we're going to move on to the cosecant function. Something I want you to remember is that cosecant is the reciprocal of 1 over sine of x. So what's nice about reciprocal functions is they look super similar to your sine and cosine functions. They just move around a little bit. So what you're going to want to do with these functions first is recognize that your period is the same. Your range is going to be a little bit different, but we'll get to that. And then the asymptotes you can actually just do after you figure out the graph, okay? With these, what I want you to do is draw your sine curve as a dotted curve first. So 0, 0, pi 1, so on, blah, blah, blah. So it looks like that. The only difference between the sine curve and the cosecant curve is that when you flip something, like we do, like say our point is pi comma 0, if you flip that, if you do 1 over the y value, it becomes undefined. So what happens is that every time you cross the midline for cosecant, you have asymptotes. Okay, so really, you probably can recognize right now your asymptotes are x equals 0 plus, how often? Every pi value, okay? Then the only other difference with cosecant is, picture this, if you have 1 over 1, it's the same point, so it still has that as a value. The only difference is, say you have 1/2 here, what happens to it? If you take the reciprocal, it becomes 2. So what this looks like is little baby parabolas every time you are at a max or a min. And that is cosecant of x. So if you draw the sine curve first, then you can put the asymptotes where you see it cross the midline, and then you can put little parabolas at its max and its min. So then we can figure out the range. Our minimum y value, I don't know why I just wrote brackets, that was silly. Our minimum y value is going to be negative infinity, and then notice where it stops. The max actually becomes negative 1, bracket because it's inclusive, union, and then it picks up again, not until that's supposed to be at positive 1, and then it goes to infinity again. Okay, so that's cosecant. We're going to do the same thing with secant. So what's nice is secant is the same idea, weight on the asymptotes and the range, but the period is still 2 pi. Remember, secant is 1 over cosine, so we're going to redraw the cosine curve first. Starts at 1, goes to pi over 2, pi, and so on. Oops, that's supposed to be dotted, sorry. I'm going to erase a little bit of that going on. Okay, so make your cosine curve dashed, because that's not actually the secant graph. The secant graph is, again, anytime this function crosses the midline, which in our case is the x-axis, you have asymptotes. And again, the reason that works is because if you end up with 0 on your x-axis, but you flip it, which is the reciprocal, 1 over 0 is undefined, okay? Then again, at the minimum, you have a little parabola. The only weird thing is, see how this is only half of a maximum? So it goes like that. Half of a maximum goes towards the asymptote. And that is the secant curve, okay? Look at your asymptotes. They're at pi over 2 plus how often? Pi n. You literally just look at the graph for that. The range, same as the cosecant graph. So negative infinity to negative 1, union 1 to infinity. Okay? Cotangent I did for you. And you can actually make a table, and notice that if you take your table for tangent and you make it the reciprocal of each of those, what ends up happening is it's basically tangent shifted right pi over 2. And then notice that these points flip-flop. So tangent is usually like here. That's usually tangent. So it flips, and then you have asymptotes there. Okay? The transformations work exactly the same, but don't worry about that too much. We're going to do a little bit more with it the next time I see you. So we're doing the reciprocal functions today, and then you guys are going to be working on a little bit of review, so ignore the cotangent questions until later, because we're going to do a lot of cotangent stuff next week. So any cotangent questions we're going to skip today. All right, we're going to try a little bit. What I would do first, again, is regraph this as negative 2 sine of x plus 1. Draw it as a dotted, and then you'll be able to answer the rest of the questions, because remember, it's based off of that graph. So one thing you might notice is that the reciprocal functions actually don't have amplitudes, but we're going to write them down just to help you graph the reciprocal of these functions first, and then it's easier to graph the original reciprocal functions back. So you can say the amplitude is 2 here, even though, again, they don't really have an amplitude because they keep on going forever in both directions. The period is still going to be 2 pi or 360, depending on what they give you. The phase shift here is none. And then we have a vertical shift, which I would add, of up 1. Okay, so we're going to graph our original function. Just be careful because it is going to be flipped of sine. Remember to graph your midline first, so it's going to start at 1. Going down 2 from there, so we're starting here, down 2, back up 2, and then back down. So your original sine curve looks something like that, because remember, you're going down first because of the negative. So then remember, your cosecant graph is just going to be asymptote, 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 parabola, parabola. And don't worry about the critical values for that, but remember, it happens every period divided by 4. Okay, so in this case it would be 0, pi over 2, pi, 3 pi over 2, and 2 pi. All right, let's try another one. We're going to skip the cotangent one, because again, I'll come back to that next week. But I would like for you to try to see if you can do number 3 for me. So pause the video, check it out. Remember, you should graph the same equation but with cosine first. Draw it as a dotted curve first, okay? So you can't make it filled in only because it's not the same function. All right, hopefully you got this far. The amplitude's 3, period's pi, no phase shift. The range is going to be negative infinity to negative 3, union 3 to infinity. If you knew that without graphing, awesome. If you didn't, that's okay. Just a reminder that the cosine curve here ends at pi, so you need to draw in the pi over 4 and the 3 pi over 4 on your axes. Again, draw in the dotted curve, which mine is terrible, but you get the idea. So that means asymptotes are going to be. So that means your asymptotes are going to be at the midline, which means they are at 3 pi over 4. Over 4 and pi over 4, because that's where you're crossing. That also means that we have our little parabolas. Sorry, it's so small. They're in there. Okay. All right, skip the next one. Try out, because we're going to do cotangents together. Try out the next, which is going to be the cosecant and then the secant. One thing just to be careful of, guys, is for number 5, make sure you factor out that 2 first. Okay, so just be careful of that. Try the next 2 on your own, and then I'll show you the answers. All right, hopefully for number 5, you got a graph that looks like this. It's all the black. So you need to just be careful to draw your sine curve in as dotted, because the actual cosecant curve is the black. So the asymptotes are at pi over 4, negative pi over 4, and 3 pi over 4, because your period's only pi. All right, and then this one is in red. Check it out. Your asymptotes are at 30 degrees and 210. If you have trouble figuring out what you're going up by, remember, divide your period by 4. So you're going up by 90s. You're starting left 60 degrees, which means you're ending 360 degrees later, which is at 300. And then we flipped. Our amplitude is still positive, even though these don't really have amplitudes, okay? So our range in this case, negative infinity to 0, and then union to infinity. That's a bracket. All right. The last 2 I would like for you to try on your own. Again, just be careful of any factoring. And then last but not least, I will show you the answer. Number 8 is a little tricky because it has a lot going on, but do your best. All right, so for the first one, you have to be careful and factor out the 2 again. So your shift is actually left pi over 2, which makes your graph look like, not that, that looks weird. That should be shifted up. I don't know what happened to that graph. But basically your amplitude is going to be 2. If you picture everything being moved up a little bit, I don't know what happened to the visual there, but your asymptotes are going to be every, it looks like pi value? Pi over 2 value. So if we move left pi over 2, your first asymptote is going to be at pi over 2 to the left, so negative pi over 2, and then it's going to happen every pi over 2 value, so pi, 0, pi over 2, things like that, okay? I'm going to try to actually redraw that graph for you because it came out so weird. So let's erase that. The bottom one should be fine. If you did not get this graph, I just wanted to do it out for you just so you could see. But it's basically you're going to start left pi over 2. So negative pi over 2 is here. It's a little cramped, but this is negative pi over 4. Try to label it if you can. This is pi over 4. Because what happens is if you take your period, which is, again, 2 pi over 2 in this case, so that's why your period's pi, and you divide it by 4, that's your critical values, meaning every pi over 4 from where you start, you have a point. So our first point is going to be at negative pi over 2. Then, at negative pi over 4, we're at our max, which is 2. Then you're back to 0. Then at pi over 4, you're at your min. Then you're at your max. So that's your sine curve. Sketch it out as a dotted line. So that means we have asymptotes at negative pi over 2, 0, and pi over 2. We also have our little parabolas at each of those points, okay? Then from there, the next one, again, make sure you factor out the 3. So you actually have a horizontal shift left 30 degrees. And your amplitude's 4. So just be careful, there's a vertical shift down 1. So draw in your midline at negative 1, okay? This is a really tight graph, so if you need a better visual of it, if you look at what I could draw over here, it might help. So draw your midline at negative 1, right? This is the reciprocal of cosine. So you're going to be drawing a cosine curve. You're starting at -1. You're going left 30 degrees. So this is like -30 degrees. And remember, you can divide your period by 4. So every 30 degrees, something is happening. The thing to be careful of here is that at -30 degrees, you're 4 above your midline. So you're actually going to start at 3. Then 30 degrees later is 0, but you're going to be at the midline. Then 30 degrees later, you're at your minimum, which is again 4 down from your midline, so you're at -5. Then 60 degrees, you're at your midline again, and then finally at 90 degrees, you are at your max again. So your cosine curve would look something like that. Make sure it's dotted though. I just did that to help you see what it would look like. And I'm just going to draw like little slashes to show that it should be dotted. And then from there, you want to draw in your asymptotes. They're going to be wherever it crosses the midline. So in this case, it's 0 and 60 degrees. And then draw your little parabolas. Okay, so that's a bigger version of what I have graphed. It's a little hard to see what it looks like. So that means your range is going to end up being -infinity. Sorry, that's a parenthesis. To -5 bracket union 4 to infinity. Okay, if you had trouble with any of these, just talk to me the next time I see you, and you can make sure that you ask each other questions as well. Have a great rest of your day, and I will see you soon.